So our next topic is Arrhenius equation. This equation gives effect of temperature on the reaction rate constant and hence the rate of reaction. We explained to you some time back that for most of the reactions rate of reaction doubles or can go up to triple in some cases with every 10 degrees Celsius rise in temperature. How it is explained to us? It can be explained using Arrhenius equation. What is equation? Equation given in the form of K is equal to A into e to power minus EA by RT. In the given equation, this K is called as rate constant of the reaction. K is called as rate constant of the reaction. It signifies the rate of reactions as well. A in the reaction is called as Arrhenius factor involving the molecule's proper orientation. I will explain this point with detail. And then EA in the reaction is called as activation energy. R is gas constant and T temperature in Kelvin scale. Temperature in Kelvin scale. T in the reaction is temperature in Kelvin scale. So in the expression K is taken as rate constant of reaction, A is taken as Arrhenius factor or parameter, EA in the reaction is called activation energy, R is gas constant, T is temperature in Kelvin scale. Okay. So before we take the meaning more of terms K and A, let us take this expression. The graph is drawn, reactant potential energy versus reaction coordinate. It can be taken the reactants average. It is the reactants average potential energy of reactants. It is average energy of products. It is of products average potential energy. Average potential energy of products up to here. It is heat of reaction. It is delta H, enthalpy of reaction. It is enthalpy of product minus reactants. This energy is called as threshold energy. This energy is called as activation energy. We have taken one term, activation energy. In the equation, वो कौन सा है? It is given here, activation energy EA this much. Okay. It is taken the reactant threshold energy. Now for explanation of the rate of reaction first, we explain from the given expression and this way. This graph. देखिए when we have reactant molecules, आपको reactant दिए हुए हैं, तो how they can convert to product. The reactants are colliding among themselves. The reacting molecules are colliding among themselves. In those collisions, certain collisions are effective in nature. Only some collisions are effective in nature. In effective collisions only, the reacting molecules can convert to product. Now, how many collisions among them can be effective in nature? That we explain through the given graph. देखिए, in collision of molecules, some of the reactants can go up to here, means energy exchange take place. Now we don't have ideal gases, but we have real molecules in which the collisions are not elastic in nature. The collisions among the molecules are inelastic in nature. In those inelastic collisions, the molecules will gain some energy and their energy increases. So in collision of molecules, some molecules can come up to here after energy gain, some can come up to here, some can come up to here. But those collisions in which energy remains less than threshold energy, they cannot convert to product. They cannot convert to product. How much energy required is minimum? That energy is called as threshold energy. That energy is called as threshold energy. So if you take definition first taken here of threshold energy. What is threshold energy? Definition, you can write down the previous definition. It is the minimum amount of energy. It is the minimum amount of energy that the reactant molecules should have to cross energy barrier. It is called energy barrier. To cross energy barrier and convert to product. To cross energy barrier and convert to product. Means इससे कम अगर एनर्जी होगा तो those molecules cannot form product because they cannot cross energy barrier to form product. This energy can be taken how much? This energy can be taken, this threshold energy is equal to, right here, it is equal to average potential energy of reactants plus activation energy of the reaction plus activation energy EA. So for the reaction threshold energy we can take is equal to how much? It is equal to reactants average potential energy plus activation energy. When we add both values, this becomes threshold energy. Below this energy, the reactant molecules cannot convert to product. Then how we define this term? Activation energy. Activation energy EA. How we define this term? Activation energy. You can add definition. लिख लीजिए इसका definition. It is the additional amount of energy. It is the additional amount of energy that must be acquired. It is the additional amount of energy that must be acquired by the reactant molecules. By the reactant molecules. By the reactant molecules to cross energy barrier and from product. To cross energy barrier and from product. Meaning क्या होता है? It is the additional amount of energy means it is the energy. If I can take other way definition also, it is the amount of energy that should be acquired by the reactant molecules in addition to their own average potential energy. To become how much? To become this much, so that they can cross energy barrier. So that they can cross energy barrier. To explain this, let us explain through one example through daily life. Suppose in a school we are having high jump competition. Yeah, suppose at a state level. At state level we have a high jump competition of class, let's say 11-12 students. The student of reading in 11-12 class or those who are interested, they have to go for a state level competition for high jump. Now from each school they can send at the max 1 or 2 students only, because in a state we have so many schools. So among those many students from many schools, only few students are going from each school, maybe 1 or 2 only, which they think they're best. They are sent for the high jump competition. Now how they are selecting the students? Like in the school morning prayer, they will announce by the school authorities that those students who want to go for a high jump competition at national level, please assemble in the ground. High jump competition, they have to go for the school level competition at state level then. So first they have competition at state level, school level. Suppose each student want to go for कि हम जाएंगे. Okay, those are interested, they are going to the school ground. Now how to select? मान लो आपके भेजना है 2 बच्चे और बच्चे पहुंच गए वहाँ पे 50 कि हमें भी जाना है हाई जंप कंपटीशन के लिए. तो they will make a queue. The student will make a queue and then they said कि they put a small barrier कि चलो start हो जाओ. Then the student are crossing that small barrier. तो many students are out in the first round. उछल ही नहीं पाएंगे, उतना भी नहीं छोड़ पाते हैं, तो वो बाहर जाएंगे पहले राउंड में. फिर क्या होता है इसमें? Now suppose after first round around 10 students are remaining. 40 बाहर हो गए फर्स्ट राउंड में कि उतना हाई जंप कंपटीशन जो उन्होंने रखा था उसको पार नहीं कर पाते हैं। अब जो बचे 10, तो फॉर देम दे विल टेक सेकंड राउंड, हाइट ऑफ द बैरियर विल बी इंक्रीज। अगेन आउट ऑफ दोज 10, 2-3 will eliminate, height of the barrier keep on increasing for each stage. So what happen ultimately, 1 or 2 students only are able to cross that higher level of the barrier. So only those students who can cross higher level barrier are selected to represent the school at state level. Then it happens from many schools. Suppose even from single school one student is going, so we can have 1000 schools, so we can have 1000 students. Again they go for school level state level competition. वहाँ पे क्या होता है, again suppose they will get many students, so they will make some groups, each group they will select 1-2 filter करेंगे उसमें से. तो we can think same way कि it is like again one level they fit कि ये level कम से कम इतना है, इसके ऊपर होगा तभी आप कंपटीशन में जा सकते हैं. तो they can put one level. So again they will make many students to stand out. Some can come up to here, some can come up to here, some can come up to here, some can come up to here. But those which are lying below this level, they cannot be qualified. So they will put some qualifying mark, height. आपका भी होता है एंट्रेंस में, you have a cut off mark. इससे कम पे तो आप क्वालिफाई कर सकते नहीं हैं. इसके ऊपर होगा तो आपका रैंक बढ़ेगा उसके बाद. Same thing also happen. Out of thousands of collisions in molecules, only very few collisions are effective in nature. Then which are the effective collisions? Only those collisions in which the molecules can acquire energy at least equal to threshold energy. Guess the definition? It is the minimum amount of energy that should be possessed by the reactant molecules to cross energy barrier. It is called energy barrier. कि they should have energy at least equal to threshold energy. उससे कम अगर एनर्जी रहेगा उसका मॉलिक्यूल्स का तो they cannot cross energy barrier and they cannot form product. They cannot convert to product. I hope आपको समझ में आ रहा होगा ये पॉइंट. तो वही है इसमें कि इतना एनर्जी है, इतना और चाहिए, एक्स्ट्रा इतना चाहिए. That extra energy is called as activation energy. कि molecules are possessing already some energy. To energy of the molecules to become equal to threshold energy, they require how much additional amount of energy? That energy is called as activation energy. Like suppose in one day, one more example to explain this. कि आप घर में बैठे आराम से, आप घर में बैठे हुए हैं और मम्मी को कुछ सामान का रिक्वायरमेंट पड़ गया है कि आपकी मम्मी को कुछ सामान चाहिए और आप अकेले घर में हैं इसमें जो सामान ला सकते हैं. तो आप पैसे लेंगे मम्मी से कि हाँ दे दीजिए, मैं लेके आता हूँ सामान को, लेके आता हूँ, आती हूँ. अब आप पहुँचते हैं शॉप के ऊपर. तो शॉप पे क्या होता है कि आपको जो कॉस्ट, जो चीज़ खरीदनी है, मान लो उसका कॉस्ट है 150 रुपीज़ और आपको पैसे दिए मम्मी ने 100 रुपये खाली घर से, कि आपकी माँ ने आपको 100 रुपये दिए हैं कि बेटा 100 रुपये ले जाओ और आपको ये चीज़ लेके आना शॉप से जाके. आप दुकान में पहुँचते हैं, कॉस्ट पता चलो दुकान पे कॉस्ट उसका है 150 रुपीज़, या छोटा पैकेट नहीं है बड़ा पैकेट ही है और आपको चाहिए. तो क्या हुआ, आपके पास जो 100 रुपये हैं वो हो गया आपका एवरेज एनर्जी. यू कैन थिंक दैट इज द रिएक्टेंट्स एवरेज पोटेंशियल एनर्जी. कितना कॉस्ट है उसका, 150 रुपीज़ है. इट इज ए फिक्स प्राइस शॉप. यू कैन नॉट बार्गेन कि भैया 100 रुपये का ही दे दीजिए. आप बार्गेन नहीं कर सकते शॉप पे, ऐसे आप मांग सकते हैं. तो क्या होता है, आपको वो चीज़ देनी है, उसका कॉस्ट है 150 रुपीज़. कितना कम पड़ गया, 50 रुपीज़. तो उस चीज़ को परचेस करने के लिए आपको और चाहिए 50 रुपीज़. तो जो आपके पास था 100 रुपये वो हो जाएगा इस केस में रिएक्टेंट का एवरेज पोटेंशियल एनर्जी. कॉस्ट उसका है 150 रुपीज़, वो हो जाएगा थ्रेशोल्ड एनर्जी. उससे कम पे तो आपका जो चीज़ आपको लेनी है आपको मिलेगा नहीं. कितना और चाहिए, 50 रुपीज़. वो आप कहाँ से लेके आएंगे, अगेन आइदर गो टू हाउस, टेक द 50 रुपीज़ मोर एंड अगेन गो टू शॉप, परचेस थिंग एंड कम बैक टू होम. सेम थिंग ऑल्सो वी कैन थिंक ऑफ हियर कि इतना एनर्जी है, इतना कम से कम चाहिए, इससे कम पे रिएक्शन आपका पॉसिबल नहीं है. तो कितना कम पड़ेगा, जो कम पड़ेगा वो हो जाएगा उस रिएक्शन या चीज के लिए एक्टिवेशन एनर्जी. समझ में आपको आ रहा है नहीं आ रहा है? So that is how you can take the meaning of term activation energy. It is the additional amount of energy, or it is the amount of energy which must be acquired by the reactant molecules in addition to their own average potential energy, so as to cross energy barrier, because only those molecules which can cross energy barrier can form product if they also have proper orientation. If they are proper orientation, दोनों चीज चाहिए आपको इसमें. They should have proper sufficient energy and also proper orientation. So in the given term, energy part is explained by this case. एक टर्म को और लिखा है यहाँ पे A. So let us take slight more meaning of this capital A. In the reaction, this K is called as rate constant. Basically, this K will signify the number of effective collisions per unit time. This K is called as rate constant. It signifies the effective collisions frequency. Okay, I'll write here. So in this case, what is K? This K will signify effective collision frequency. And what is A? A is called as, different names are given for A. Already I told you one name, it is called as Arrhenius factor. It is also called as pre-exponential factor. It is called as Arrhenius factor. It is also called as pre-exponential factor, or it signifies the collision frequency factor of molecules having proper orientation. A signifies collision frequency factor of molecules having proper orientation. This A can be given as product of P into Z. Z can be taken collision frequency of all molecules, and P is taken the factor including this. Z is collision frequency. Only collision frequency part is Z. I can write here. Z is only collision frequency. And P will be taking the fraction of molecules which are undergoing collisions having proper orientation. So for the collision of molecules to result into product formation, they have two requirements: that they should have sufficient energy and also they should have proper orientation. Suppose they have only orientation proper but not sufficient energy, they cannot convert to product. Or if they have only sufficient energy but not proper orientation, again they cannot convert to product. For the collisions to be effective, in which the reactant molecules can convert to product, they should fulfill both requirements. The molecules should have sufficient energy as well as proper orientation. इसका meaning क्या है proper orientation का? I'll explain to you. Let us take one reaction of H2 plus I2 giving 2HI. How the reaction takes place? When the reaction occurs, if I write here H2 molecule, this is HH bond, it is I2 molecule. When the reaction takes place, what happens? They will form one transition state showing the old bond breaking and new bond forming, and after reaction completion they can give 2 moles of HI. It is called as what here? Transition state. called as activated state. Now let us take for this collisions to be effective in nature, how the molecules can have proper orientation. If I write one hydrogen molecule, one I2 molecule, H is small size having covalent bond, I2 bigger having covalent bond. So in this case, if the collision of molecules take place in these sites or positions, it is one example of molecules having proper orientation. इसका मीनिंग क्या होता है कि मॉलिक्यूल्स है प्रॉपर ओरिएंटेशन? इसका मीनिंग ये होता है कि आपके मॉलिक्यूल्स में जिन एटम को नए बॉन्ड बनाना है, मॉलिक्यूल्स में जिन एटम के बीच में नया बॉन्ड बनेगा वो सामने आना चाहिए, वो पास में आना चाहिए. दे मस्ट कोलाइड डायरेक्टली. HI कोलाइड होना चाहिए दोनों मॉलिक्यूल्स का यहाँ पर. तो इट कैन बी टेकन मॉलिक्यूल हैविंग प्रॉपर ओरिएंटेशन कि हमारा नया बॉन्ड कहाँ बनेगा? H और I के बीच में. तो H I से ज्वाइन होना चाहिए या कोलाइड होना चाहिए यहाँ पर. तो कोलिजन should take place between H and I of two molecules. यहाँ पे देखिए, if I take second example, if molecules are having improper orientation, H2 molecule, it is I2 molecule. Now they can collide only in one position. Collision can occur at only one point, or collision can occur at different points. So this can be the examples of what? Here the example of molecules having improper orientation. Improper orientation. One is the example of molecules having proper orientation, other taken molecules having improper orientation. For the collisions to be effective in nature, they should have proper orientation as well as sufficient energy. उनमें energy भी चाहिए plus they should also have proper orientation. अगर एक भी missing होगा, collisions cannot result into product formation. And in the given graph we discussed sometime back, this highest energy point in the graph will be taken as, it is supposed to reactant, it is product. Highest energy point is taken as, I write TS, or I can write it here itself. Highest energy point is taken the molecules having molecules in the transition state. In the given graph we have discussed energy and reaction graph. Highest energy point will be taken the energy indicative of the transition state in the given graph, or energy in the activated state. From here they can convert to product, or they also can come back to the reactant. Reactions can be two categories, reversible or irreversible accordingly. Anyway, it is taken the meaning. So I hope it is clear. It is the example taken of molecules having proper orientation. So in the given graph there are two things. One part is A. A signify the molecules having proper orientation. A is including your molecules collision frequency into fraction of molecules having proper orientation, and second part signify energy part. So actually what happens is help in crossing over energy barrier. You have two barriers for the collisions to be effective in nature. This part will explain energy barrier part, and second part taken indicate or explain orientation barrier. Orientation barrier. For a collision to be effective in nature, there are two barriers. One is called as energy barrier. That means they should have sufficient energy to convert to product. They should have how much energy? They must possess energy at least equal to or more than threshold energy. So they already have some energy. वो तो उनका है, अपना खुद का एनर्जी है, उसका टेंशन नहीं है. कितना एनर्जी और चाहिए उनको एक्स्ट्रा, वो होता है रिएक्शन का एक्टिवेशन एनर्जी. इनका एनर्जी इतना था ऑलरेडी इनके पास. दैट इज द रिएक्टेंट्स एवरेज पोटेंशियल एनर्जी. कितना एनर्जी और चाहिए वो होगा रिएक्शन का उनके लिए एक्टिवेशन एनर्जी. तो दिस पार्ट विल कंट्रीब्यूट अबाउट द एनर्जी पार्ट. एनर्जी बैरियर एक्सप्लेन. And this part explain the molecules having proper orientation, including the molecules collision frequency factor. So I told you this K will signify the effective collision frequency. Effective collision frequency means for collision to be effective in nature, they should satisfy or cross both barriers. They must overcome both barriers. They should have molecules having sufficient energy and proper orientation, and those only molecules in which the reactant molecules can have sufficient energy and proper orientation can convert to product. K is called as rate constant, but this K will signify simply effective rate or effective collision frequency for the reaction. So I hope it is clear. From this expression we can add 1 to more points. I can add this equation in log base 10 form also. Log 10 if I write here log K, log base 10, K is equal to log A minus EA upon 2.303 RT. Now in the given expression if I write here, this A is taken collision frequency of molecules having proper orientation. Sometimes the question is asked certain points, like first point is taken, what is fraction of reactant molecules in activated state, or this also can be taken fraction of reactant molecules having sufficient energy to react. That fraction will be how much coming? This fraction can be given as, let this fraction as f, can be given as K by A or e to the power minus EA upon RT. Can be given as K by A or e to the power minus EA by RT. So in question they can use the two words here. They have used two words in questions. What the fraction of reactant molecules in the activated state or in the transition state, or it is same as fraction of reactant molecules having sufficient energy to react or to cross energy barrier. K will signify effective collisions and A is signifying total collision frequency of molecules having proper orientation. Out of those many collisions, what fraction is effective? K. So ratio of K by A become fraction of molecules which can form product, or it is e to the power, if it is K by A will be how much? E to the power minus EA by RT. That K by A will be equal to e to the power minus EA by RT, or from here you write log K by log A is equal to minus EA by 2.303 RT. So anyway you can write expression this way, from here or from here can modify as per calculation, easy method. That is one point. Second point they ask in the reaction, before the reaction what is maximum rate constant? Before the reaction what is maximum rate constant, it is given as equal to capital A only. For the reaction, what is the maximum rate constant? So again directly, for the reaction, the maximum rate constant of reaction can be taken equal to capital A. How it is possible? You can be say it is possible if temperature approach infinity or EA becomes 0, then what happens? K become equal to A. You can see from here, if EA becomes 0 or T become infinity, in either case this portion becomes 0, then log K become equal to log A, then log K become equal to log A. So what you can say here, then K become equal to A. So when you take K was taken rate constant and A is taken then reaction maximum rate constant, because A become equal to K when T approach infinity or EA become 0. Meaning क्या होता है? Now when T will be infinity or EA will be 0, we have only one requirement, that the molecules should only possess proper orientation. वो कहाँ पे है? That is already included in capital A. So whenever the molecules are having T infinity or EA 0, in both the cases K become equal to capital A. K is a rate constant, become equal to reaction maximum, that become equal to A. A in the reaction is called as maximum rate constant. I hope it is clear to all of you. This concept, यहाँ पे काफी टर्म important है वाला. Question पूछते हैं इसमें frequently कि for the reaction what is rate constant when T approach infinity? It is more common. T approach infinity. बहुत simple है. When T infinity, this term is 0, so K become equal to A. In that condition, K will be equal to A. Or they ask for the reaction as a whole simply. For the reaction, what is the maximum rate constant? तो वो कितना है? Simply equal to capital A. I hope इतना पार्ट क्लियर हुआ होगा पूरा. चलिए. Now to see the effect of temperature, we can write expression once again. Log K is equal to log A minus EA by 2.303 RT. Now first we take some points more before we move further. In the given expression, this can be taken the equation of straight line. This can be taken the equation of straight line. Like you can take y is equal to mx plus c type. So you can draw the graph here. Log K versus 1 upon temperature. We get negative slope. For the reaction, slope can be taken minus EA upon 2.303 R, and we will have how much intercept can be taken? Log A along y-axis. This can be like my equation of straight line. It is y. If I draw the graph 1 by t करके, तो m x plus c. So we can take in this case, we will have slope minus EA by 2.303 R. If I take log natural, if I suppose write in this case expression as ln, if I write ln k 1 by t, then slope can be taken how much? Minus EA by R. So be careful. In the question, the graph given is ln k or log base 10k. It is log base 10 I am writing here. Expression, then we get this graph. बाकी term same रहेगा. It is ln A now as intercept along the y-axis. Now in this case, 1-2 point you can see more. Okay, the reactions which are having high activation energy, more in magnitude, slope will be higher, and reactions having lower activation energy, slope will be less. So sometimes the slope can also indicate or can help you to find the comparison of approximate activation energies. Like if I write here, this reaction having high in same graph activation energy On the other hand, if I draw the graph of this nature of reactions having low activation energy, so reactions having high activation energy, slope is more, and low have slope very less. So I hope it is clear. So sometime on this graph base you get questions, slope is given, find activation energy. In this case be careful, if the slope is given and they ask to find the activation energy, we can find for the reaction activation energy in either joules or calories. हम क्या करेंगे इसमें? We will find the reaction activation energy in joules or calories. If it is taken in calorie or joules, value of R to be taken in same units. EA क्या लेंगे हम? Activation energy किसमें लेंगे? अगर हम लेते हैं joules में, take value of R 8.314 joules per mole per Kelvin. About units, be careful. बच्चे बहुत गलती करते हैं, सिली मिस्टेक उसी बोलते हैं कि अगर आपने R के वैल्यू में एक बहुत कॉमन मिस्टेक बच्चे कर देते हैं, तो आपको वो कॉमन मिस्टेक नहीं करनी है, सिली मिस्टेक नहीं करनी है. बी स्मार्ट, डोंट बी सिली. R and energy must be taken same units, either both in joules then both in calories. If we take calories, तो R कितने लगेगा इसमें? 1.97. we take 2 for doing questions. We take value of R 2 calorie per degree per mole. If R is taken in calories, then we get the activation energy in calorie units. So R and activation energy must be taken in same energy units. Are you clear? That's how we can proceed for this example of reaction. Now to see effect of temperature on the rate constant of reaction mathematically, I can write K1 as the rate constant at T1 temperature. In small variations of temperature, A, Arrhenius factor and activation energy EA will remain unchanged, will remain almost constant, and in your question comparison we say they will remain constant. In small temperature range, activation energy and capital A, they will not change, they will remain same. That you can take assumption. So when it is taken at T1 temperature, K1 is the reaction rate constant, and then if I take here at T2 temperature, K2 is the rate constant. So how we write expression? EA by 2.303 RT2. At T1 temperature, K1 is the rate constant, and at T2 temperature, K2 is the rate constant. EA will remain constant, A will remain constant in the given temperature range. That EA and T will remain same in given temperature range. So when you take ratio, means subtraction, 2 minus 1, log K2 minus log K1 is, I can write log K2 by K1 is equal to how much? Log A cancel out, I can write here EA by 2.303 R. I write here, देखिए आपको माइनस था, माइनस को प्लस किया कर इसमें 1 by T1 minus 1 by T2 और log K2 by K1 can be written as EA by 2.303 R T2 minus T1 by T1 T2. This expression will give effect of temperature on the reaction rate constant. On the reaction rate constant. This equation gives effect of temperature on the reaction rate constant. In the given case, EA value is always positive. So if T2 is more than T1, then K2 become more than K1. For all the reactions, EA value is always positive. It cannot be negative. So what happens if EA is positive? Then with rising temperature, if T2 is more than T1, this positive value increases. So what happens with rising temperature? There is increase in the reaction rate constant. Rate constant increase means rate of reaction increase. If the rate of reaction means if the reaction rate constant increases, then for the reaction rate of reaction will also increase. I hope you are getting this point. With rising temperature, rate constant increase. When K increase, rate of reaction will also increase. Okay. That is how we can take explanation of effect of temperature on the reaction activation energy. We will solve questions on this point more after taking some more theory of this topic. Now sometime the question they ask relation of activation energy of forward direction and of backward direction with heat of reaction, delta H of reaction, enthalpy of reaction. Relation of activation energies of forward reaction and backward reaction with the enthalpy of reaction, delta H of reaction. See, reactions can be taken in two types. Reaction can either be taken exothermic in nature or reaction can be endothermic in nature. R is reactant, P is product. So it's the graph first we take from, means it is same reactants potential energy and reaction coordinate. यहाँ भी दिया reactant का दिया है potential energy reaction coordinate. It's the graph for endothermic reaction and it's the graph for exothermic reaction. In endothermic reaction, delta H is positive, while we take for exothermic reaction, delta H will be negative. Here delta H is positive. Now in either case, we have two directions. One is taken forward direction. In this case, for the forward reaction, it can be taken activation energy, I write EAF. While for the backward direction, it behaves as reactant, this we can behave as product. So for the backward reaction, I can write EAB as activation energy. EAB as the backward reactions, activation energy. In this graph can take here, this can be taken EAF, forward reactions, activation energy, and for the backward reaction, this can be taken as activation energy. So in either graph you can compare or see, we have a common expression of observation that for the reaction, heat of reaction is how much? EAF minus EAB. We can use for common for any equation. देखिए इसमें क्या है आपका EAF क्या है इस रिएक्शन में? EAF is the activation energy, EAF for forward reaction, while EAB, ये तो कॉमन टर्म आपका है एक्टिवेशन एनर्जी, B for backward reaction. EAF is taken for the forward reaction, activation energy. EAB is for the backward reaction, activation energy. Formula will be same. If it is taken endothermic reaction, it is positive. Positive का meaning क्या होगा? Sorry. If EAF is for endothermic reaction, EAF is higher than EAB, lower in magnitude, this value become positive. While for exothermic reaction, EAF is lower, EAB is more in magnitude, but दोनों positive है, EAF भी positive है, EAB positive है. It is lower in magnitude, negative value high become in magnitude. So what happens in this case? Delta H of the reaction will be negative. So remember, for a reaction, enthalpy change can be negative or positive. But for the reaction activation energy, but for a reaction the activation energy will be always positive, is always positive. So if I combine both the points, actually आपने लिखा ये पॉइंट पूरा लिख लिया, आई होप आपको क्लियर होगा इसमें. ऑन दिस पॉइंट यू गेट क्वेश्चन फ्रीक्वेंटली इन योर डिफरेंट एंट्रेंस एग्जामिनेशंस और ओलंपियाड्स एटसेट्रा. तो इट इज वन कॉमन एग्जांपल, बहुत सिंपल है. फॉर देखिए क्या होता है कि फॉर ए गिवन केमिकल रिएक्शन डेल्टा एच रिमेन सेम इन मैग्नीट्यूड फॉर द फॉरवर्ड एंड बैकवर्ड डायरेक्शन, but sign of delta has become opposite. If forward reaction is endothermic, then the backward reaction become exothermic. Then the backward reaction become exothermic. That point you have to keep in mind. Relation of activation energy for forward and backward direction. They are lower. They can be lower or higher, but always positive. So delta H can, however, be negative or positive, depending on the nature of reactions. If you can remember in topic chemical equilibrium, we have expressed effect of temperature on the reaction equilibrium constant. In that case, with rising temperature, value of Kp or Kc may increase or decrease. But in kinetics, with rising temperature, since Ea value is always positive, for the reaction rate constant will always increase. For the reaction the rate constant will always increase. So that point you keep in mind. Okay.